So hi, my name's Marina, and I did mine on wind and dissolved oxygen. So what is dissolved oxygen? So like land animals, marine animals also need to breathe. So as the water passes through their gills, microscopic bubbles of oxygenated gas, which is dissolved oxygen, transfers from the water into their blood. But unlike the terrestrial environment, the marine environment has limiting factors of oxygen. So it's harder for them to get oxygen than it is for us. Because the oxygen in the air is 21%, which is a lot higher than the oxygen level in the water, the oxygen in the air actually can diffuse into the water. But the main majority of the oxygen comes from photosynthesis. So my question was, there's many factors that influence the level of dissolved oxygen, such as temperature, salinity, stream structures. But what about wind speed? So I tested the effects of wind speed on the amount of dissolved oxygen in the water at Dolphin Island Sea Lab from June 1st to June 30th, so the whole month of June. And I hypothesized that the wind speed increased, so the level of dissolved oxygen in the water due to the increase of surface area and the mixing of water would increase the level of dissolved oxygen. So it's like the theory of like adding a cube sugar into your coffee and you stir it and it diffuses easier. So I'm guessing that the wind would actually help diffuse oxygen in the air into the water. So my method was I went to a website. It's called the My Mobile Bay. So it's like right here, and you just click on Dolphin Island. And you get your wind speed here, and you get your dissolved oxygen. I took milligrams per liter. So from the data, I collected the levels of dissolved oxygen at the highest wind speed and the lowest wind speed, and I compared them. And I went through 2,400 datas. Okay, so I had one for each day, and oh, you can't see that. Blue is the level of at the highest wind speed, and red is the level of dissolved oxygen, the lowest wind speed. So you can see there's a pattern at every single. What happened? Oh my god. Okay, so you can see there's a pattern here. At the highest wind, it's always like slightly higher. I did think about other factors, such as what if it was a cloudy day and it didn't get sunlight or something, and that would influence the levels of dissolved oxygen. But for the majority of the days, it showed the same pattern. So these are the next 15 days of June in the same pattern. And I also observed that when I was looking through my data, there was a pattern, and I put it into a graph, and every single day had this little peak here in the afternoon. Why? Because from like the sun rises around 6 o'clock here, and it goes down around 7 in the afternoon. So here in the middle is the peak of where there's the most sunlight in the afternoon. So that would increase the photosynthesis. So that was also what I saw in a pattern for like every single one of the days. So, conclusion. My data supported my hypothesis in the level of dissolved oxygen in the water, but only slightly. Although there was a pattern, it was like decimal point. So I wouldn't really take it into like it really did support my hypothesis. I think my research was flawed in that I didn't contribute all the other aspects of it, like the temperature, the salinity, and I couldn't control that. So if I was to redo this, I would put it into a more controlled environment, such as like what if I could do it in a tank or something and control the wave patterns. So then again, more oxygen dissolves in the wind because the wind stirs it. And then I want to thank the Dolphin Island Sea Lab, the University of South Alabama for giving me the scholarship, Jenny Cook, my mentor, she's awesome, Dr. Tina Miller-Way for guiding me through it, Dr. Ramkasoon for giving me the scholarship, Ms. Mullins, my teacher, all my counselors for answering any questions that I have, Atia, Christy, and Sarah for helping me with my data. Any questions?